Hello everyone, welcome. In this presentation, I'm going to talk about a new measure I developed as part of my PhD, which I called Spaces for Communication Index. And I'm going to show you how this measure can be used for the design of hospital wards as well as co-working spaces. I would like to begin this presentation with an image of Florence Nightingale, which was a British nurse, and during the Crimean War, she noticed that a lot of soldiers were dying in hospitals because of poor conditions there. Nightingale used these observations and the data she collected during the war to propose some design principles to be used in new hospitals, which advocated for well-lit hospital wards with natural ventilation, with no more than 30 beds in a ward, and with a central nursing station so nurses can have good visibility towards patients. And this is what we now know as the Nightingale ward. And this was also the first time that we pay attention to the layout of hospital wards and how they affect patients. Later on, researchers focused on developing measures that measured space efficiency and travel distances and the impact of the ward on travel times. And that was quite a cost-driven way to optimize for hospital wards and the design of hospital wards. One such measure was the Yale Traffic Index, developed in the 70s in Yale New Haven Hospital, where researchers observed different healthcare providers in several hospital wards and developed this traffic index. They argued that this index can be used to benchmark hospital wards and to be able to identify those layouts that are more efficient than others. However, the researchers failed to relate this measure to any outcome variables such as staff performance or duration of stay in the hospital for patients. They also failed to relate this measure to any social variables, such as, for example, communication or exchange of information, which is actually quite important in healthcare environments. And various researchers later on have proved that communication is quite important for the provision of healthcare. So thus I wanted to create a measure that focuses on space effectiveness rather than just space efficiency and takes into account communication and exchange of information between healthcare providers. And I came up with this Spaces for Communication Index, and in the next slides I'm going to explain how I actually calculated the index. So initially I used 6 different hospital wards in 3 different hospitals. 3 of those were intensive care units and the other 3 were general nursing wards. And as you can see, those wards were varied in terms of size, in terms of configuration, in terms of the typology of the ward or the number of single patient rooms. In each of these hospital wards, I conducted observations and I follow different healthcare providers, recording their movement patterns. So in total, I observed 102 members of staff for 75 hours. And based on these observations, I identified the 4 most frequently traversed paths in a hospital, which were going from one patient bed to another, going from a patient bed to a nursing station, going from a patient bed to a medicine cabinet, or going from a nursing station to a medicine cabinet. And again, based on my observations, I calculated how frequently those paths were traversed in terms of a percentage of a total movement paths. So for example, going from one patient bed to another patient bed constituted 37% of the total travel movement in the ward. And then, instead of taking into account the whole hospital, I split the hospital in different assignments. So one nurse assignment constituted of a nursing station, the nearest medicine cabinet, and the closest beds to that nursing station, assuming that whenever a nurse is working on a ward, they don't go from one end to the other end of the hospital ward, but they mostly move within the boundaries of those nurse assignments. So, for example, in this hospital, I had 3 nurse assignments because I had 3 nursing stations. In order to understand the spatial configuration of the ward, I use a method called space syntax, which was developed in the 70s at University College London. And what the method tells us is what a healthcare provider can see from a specific vantage point, and it highlights the size and the shape of the visual field of healthcare providers. This information is used to create the visualization you can see here on the right-hand side, and is used to calculate a measure called connectivity, which shows us areas with high visibility, which are highlighted in red, and areas with low visibility, which are highlighted in blue. So I use this information to calculate another measure called accumulated connectivity, which shows how much exposure one had to meet other people. The way I did it was to sum up all the connectivity values along the movement path of a healthcare provider, thus coming up with a certain number that indicated how much connectivity they accumulated along their way going from one key location to another. And using my observations, I correlated this measure to communication, and I proved that the higher the accumulated connectivity, the more communication instances, or the more frequently healthcare providers communicated with other healthcare providers. So accumulated connectivity could be used as a proxy for communication opportunities. And then, in order to develop my index, Spaces for Communication Index, I used those 4 different links that I identified earlier. The frequency, I used the percentage, how often they were traversed, as this frequency percentage as a number. And then I calculated on average how much connectivity was accumulated between every single link. I multiplied the frequency by the accumulated connectivity, coming up with a number. Then I sum up all these numbers, coming up with another big number, and then I divided this by the number of beds in the ward to account for the size of the ward, resulting in a number which I called Spaces for Communication Index. And my hypothesis was that the higher this index, the better, because this means that healthcare providers had more opportunities for communication in the ward. But in order to test this hypothesis, I used another 31 case studies, and I chose these case studies based on their quality of care rating. 5 of those were rated as outstanding, 11 were rated as good, and 15 were rated as inadequate. And I wanted to see if those hospital wards which are rated as outstanding would be those that have high psi value, and those rated as inadequate would be those that have low psi value. So I tested this hypothesis, but I also tested if the size of the ward mattered for healthcare quality, if the average connectivity of the ward mattered for healthcare quality. I also looked into the Yale Traffic Index to see if it actually correlated with healthcare quality as well as size. And what my results show was that actually connectivity and Spaces for Communication Index are good predictors for healthcare quality. However, psi was a much better predictor. And for those of you who are familiar with statistical analysis, you can see that the p-value is lower than 0.05, which means that there is less than 5% chance of a random result. So this kind of shows the importance of having psi as an objective method to be used in the design of hospital wards, and to be able to compare different designs to anticipate levels of interaction between healthcare providers. So now, some of you may ask how we can design for higher psi value. In order to answer this question, I decided to look into two different hospital wards. So what you can see on this slide are those 31 hospital wards I use for testing psi. And I chose one hospital ward that had a good healthcare quality rating, and another hospital ward that had inadequate healthcare quality rating. Both of these wards were from the same hospital, so they were relatively equal in terms of size. And I tested 3 different design changes. So the first one was to increase the width of the corridor. So I increased the width of the corridor by 50 centimeters. The second one was to create a larger open space at key locations with high connectivity. So in this case, I chose those 2 end areas, and I basically just deleted the walls there, so I can create a big open space to increase the connectivity. And then the third option was to look into to change the size of the nurse assignment. So, for example, the nurse assignment could be either centralized or decentralized. So I wanted to see if one or the other had a bigger influence on the psi value. And so here you can see the results of this little experiment. So on the very left-hand side, you can see the 2 wards and the psi values in red. And then you can see the 3 different design options. And what you really need to pay attention to is the big bold red numbers on the top of each ward. So those numbers, they show us the increase, how the design change increase psi value. And you can see that by creating larger open spaces, increase the psi value in one of the wards by 43% and in the other one by 10%. So this was the design change that basically increased the psi value the most. So these are just experiments, and of course a lot more case studies needs to be explored, but it just gives us some sort of an idea how we can actually design for psi value, and it can be used by designers in the future to test different design options. So now a little bit about the application of psi value in the psi index in co-working spaces. So I decided that to test psi in co-working spaces because of several different reasons. The first one is because communication in co-working spaces is as important as in hospital wards. So members of co-working spaces they go there because they want to talk to other people, to exchange ideas and knowledge, and this is really important to them. So I thought, okay, psi may be applied to hospital wards, but it could be also where communication is important, but it could be actually applied to co-working spaces where communication is equally important. The other reason to test psi in co-working spaces, it's very similar to hospital wards. Designers of co-working spaces, they can't really predict how a co-working space would behave, and if they would provide more opportunities for interaction. So I thought maybe this would help designers to actually design better co-working spaces that would provide more opportunities for interaction. And the third reason was because psi can also actually help members to choose in which co-working space they want to work, and also which seat to choose. And I'll show you now how this works. So I chose 6 co-working spaces, all based in the States. 5 of those were WeWork co-working spaces and 1 industrial. And the reason I chose these co-working spaces was because their floor plans were available on the internet. And as most of you probably know, for example, WeWork, they have certain criteria of designing co-working spaces. They have in-house architects that follow those criteria and recommendations. So they all should be pretty much the same or feel the same way and provide equal opportunities. So, and because I didn't have any sort of observational data for those co-working spaces, I use, together with brainybirdz, we use our knowledge of co-working spaces first to identify, similar to the hospital wards, to identify the most frequently, the key locations in co-working space and the most frequently traversed links between those spaces. And again, because there was no observational data, I tested different scenarios with different weighting of those links to check if there is any difference between the scenarios. What the results show was that there wasn't actually a great difference between the different scenarios. So, for example, what you can see here, this is one case study, and then these are the psi values for the first scenario, the second one, third one, and the fourth one. So there wasn't a great difference between those. So that's why we just decided to continue with scenario one and use the weighting for traversing those paths from scenario one. And what we can see on this slide is how the different case studies differ in terms of their psi value, and they start from low to very high. And actually the lowest is 46.8, while the highest is 143.5. Which is quite interesting because as much as those co-working spaces should be pretty much the same, they have very different spaces for communication indexes, showing that not all co-working spaces are actually the same. And some of those, and the layout of some of those, may provide a lot more opportunities for interaction compared to other ones. And finally, in order to identify certain spaces or certain desks that may provide more opportunities for interaction than other ones, I calculated the accumulated connectivity by desk for 3 case studies. And you can see here those seats that have high accumulated connectivity are highlighted in red, and those that have low accumulated connectivity are highlighted in blue. So what's interesting to see is that those seats that they located in position in such a way that users or members sat there have to go from there to another key location, passing through the T-point or another big attractor. They actually accumulate a lot more connectivity than other seats that are located not on the route of passing through a major key attractor. Another interesting finding was that those seats that are in open spaces, for example, they also accumulate a lot of connectivity. So it's, for example, the WeWork case in Seattle, where all seats in this kind of open space are quite red. However, if we look at the bottom WeWork case, we can see again an open space there, but some of the seats do not accumulate high connectivity. So this kind of highlights there is some sort of a trend there, but we need to explore a little bit more to understand how actually accumulated connectivity is affected by the layout of the co-working space. So in conclusion, we developed a new tool that designers can use to benchmark design schemes of ward layouts, but also co-working spaces for their effectiveness in maximizing communication opportunities. And we would like this to see this index used a lot more in future design of wards as well as co-working spaces. In terms of design, our results identify the importance of spaces with large view sheds that people pass through on their way from one key location to the other. And the larger the area inside, the better, as more opportunities for interaction are provided. Our results also show that creating large open spaces at key locations with higher connectivity can be used as a design strategy to design for higher size score. And finally, site can help members of co-working spaces choose their seat location to maximize opportunities for interaction. So if you're interested in finding more information about this study and others conducted by brainybirdz, you can visit our blog on our website. And I thank you very much, and I welcome any questions you may have. Thank you.
I'll get the ball rolling. And I think what's interesting for me is how you, obviously the PhD was on hospitals, but yes, then you used a methodology there to look at co-working spaces. And something I'm always fascinated in is actually how we can learn from one environment and apply it to workplaces, whether higher education, hospitals, and even airports and so on. I remember there was some of the work around biophilia is based on results from hospitals. So I don't know if you've got any general views on that. How do we learn from different environments, and how do we apply and so on?
So for example, yes, no, I agree. So for example, there is a lot you can learn from airports and how airports operate, or how hospitals operate, in order to be able to optimize processes there. For example, this is one thing I can think about. Other common things between workplace environments, it's exactly what you said, biophilia. Because I had a conversation with Vanessa, she's actually here today, the other day, on the phone. We spoke about biophilia, and we spoke about applying biophilic principles in healthcare environments, but actually to improve the time basically patients spend in hospitals, especially, and also to help them with when they're in the hospital, so they can have better time. But also those biophilic principles can be applied in and should be applied in normal workplace environments and co-working spaces. So they're quite, like the biophilic principles, they may come from hospital environments and studying hospitals and patients, but those can be applied in actual workplace environments.
And your own study, I guess, was talking about lines of sight and circulation routes and how we translate the learnings.
Yes, So that's the other thing. Of course, it's like visibility. It's important in a healthcare environment because it helps us. So the way the space is configured help us with who we can see and who we can meet on a daily basis. And in healthcare environments, this is quite important because healthcare professionals, they need to exchange information. But the same is applicable in any workplace environment. And visibility is quite important in both types of environments. So it helps people to see other people and exchange information and knowledge and ideas.
Yeah. There's a couple of questions come in for you. Nicholas has asked, I'm curious about how you did the measurements on site. Did you do it with sensors or manually? I think you modeled, didn't you? So
the answer to this question is both. I used both sensors, but the sensors were mostly to record conversations between people, not actual conversations, but instances of conversations, as well as duration of conversations. But I also followed healthcare professionals and mapped where they work and what they did there. For this actual, for the development of site, I only used the information on walking distances and paths rather than any sort of other information, like, let's say, conversations.
Okay, I was just looking down for some more questions for you. I mean, someone made a comment. Annalise made a comment about we've come such a long way in terms of medical treatments and technology, but I honestly think medieval healthcare buildings show more sensitivity to biophilia than we have now. So I guess she's saying healthcare buildings are biophilic. I don't know.
Well, yeah, if you look at the history of healthcare buildings, in fact, the first buildings that are considered as healthcare buildings are the ones in ancient Greece and Rome, which the way they describe them, they look to me more like a spa center where, the person who's ill, they go there and they get treated really nicely. Then actually during Christianity, hospitals became really dark environments. And then we have then again, actually, at some point, hospitals become really nice during the Nightingale period. And then again, when mechanical ventilation was invented, hospitals became again very deep with no daylight. But I think the trend now is again to go back to those biophilic principles and to create much better environment and to bring those principles into the design.
It's, in terms of the kind of space syntax and the modelling and all that clever stuff that you guys do, are there any other techniques? I mean, do you look at things like daylight and maybe some of the physical, environmental aspects, or does it tend to be mostly spatial with that? Although daylight, of course, is a spatial thing, isn't it?
It is, yes. Well, I think what space syntax does, it looks at the spatial configuration of buildings. So it doesn't take into account daylight, for example. But I always say it's like when you design buildings, obviously space syntax and the information you can get from space syntax is just one layer of information, but there are all sorts of other layers of information. Let's say daylight is another layer of information, or another layer of information would be what you study, let's say people's personality types and so on. So, taking into account and putting together all these layers of information can inform us about the design. But space syntax mainly focused on the configuration of the building and studies how the configuration brings people together or separate them, what people can see, where they can walk, and who they can meet with.
How do you? So one of my concerns is that over the years we've seen how spaces have become more space efficient. And what's often meant by that is more dense and more cramped. And again, and we've got all these wonderful tools, and people like yourself are saying we should be doing this, and yet we still seem to have this kind of cost-driven market in the workplace industry. Any comments on that? Any help?
Well, obviously, I mean, I understand the need for a cost-driven, I understand where this need comes from, and I guess it's something, it's a requirement and it needs to be taken into account, but I don't think it should be the only factor to be considered. And that's why, when I tested Sai on co-working spaces, the idea was for example, if I'm a member of a co-working, or I'm looking for a seat in a co-working space, obviously cost would be a major factor that would dictate my choice of a desk or seat of co-working space. But this could be another factor that can help and provide a little bit of more information. So, Nigel, if you think about if you want to buy, I don't know, a nice dress, for example, you have a certain budget, or a suit in your case, and you have a certain budget, but you don't want to actually buy the cheapest one, or you want to find a compromise between something that looks good on you and it's made of a nice material, but still you can afford, and it actually, it's not overpriced. So the price corresponds to the material and the suit. So it's the same.
Yeah, I think what you're saying is that it's a value judgment, isn't it? You want maximum value, so you don't just want to go for the cheapest solution because that's not necessarily going to meet your other requirements.
Sometimes maybe you're looking for exactly the cheapest solution, but that's not always the case.
Okay, thank you.